Hello, welcome to Z Talk. Previously, we went through the procedure step by step to understand how do we deploy EKS cluster manually on AWS console or via AWS CLI. Here we go. This was the high-level procedure we demoed in our last session. Let's continue this discussion. I think now we're ready to figure out how do we automate this whole process via Terraform. If you haven't got a chance to watch the previous session and are not familiar with the configuration for deploying Kubernetes, I highly recommend you to go over there to review my previous session. Again, you needed to understand the whole procedure before you do automation. Otherwise, if something goes wrong, it will be hard to troubleshoot what's going on Terraform side. All right? Let's start with VPC. As you remember, we used an AWS service called CloudFormation to create the custom VPC to host our Kubernetes cluster in our previous session, right? Back to Terraform, we can use modules to do the same thing. As you remember, I've had a demo specifically for Terraform modules previously, so feel free to jump over there to review. Here's the link. Otherwise, let's stay here and just do that again. And I'm gonna use the shared VPC modules and on Terraform registry. Let me jump to my browser and just search for VPC modules on Terraform registry. And here we go. This is the module, and as you can see, version 3.7 is the latest. I'm gonna use this latest version. All right, and refer to these example of configuration. So let's jump back to my Visual Studio Code, and here we go. I'm going to use the latest version here, and I'm going to call these custom VPC as EKS-VPC. And regarding availability zones, as remember, for hosting Kubernetes cluster, we're going to need at least 3 availability zones. That's why I put here 0 to 2. 0 to 2, these are indexes, right? And inside of these VPC, I'm going to create 3 private subnets and another 3 public subnets accordingly based on CIDR definition right here inside of these array. All right, that's pretty much for VPC. So once we got our custom VPC configuration ready, remember there was another preparation we've got to take care of before we actually deploy our cluster, which was role, right? We had to create a couple of roles on IAM on AWS console, remember, in our last session. So we're going to do the same thing via Terraform here. So that's why I create another Terraform configuration file called IAM. Here we're going to define the roles that are required, and we also going to attach policies to those roles. Basically, we're going to need 2 roles. One is for the EKS cluster, and the other is for the EKS workers, right? So let's back to my browser and review the documentation. Let's start with the EKS cluster role. All right. When you create the cluster role, again here based on documentation, ensure that the EKS cluster policy, manage policy, is attached to the role. All right, and this is role look like. So just copy this policy and go back to your editor, and here we go. As you can see, the first resource is for creating a role called EKS cluster, right? And I'm gonna ensure that these Amazon EKS cluster policy manage policy is attached to this role. Here we go. This is the policy I copy from here. All right. Next, once we have this policy, this role ready, we need to attach a couple of policies to this role. That comes to these two, right? So you can review in the documentation or from the AWS console. But here I list out, I put a comment right here. The first policy you're gonna need is for the AWS EKS cluster policy. This policy provides Kubernetes the permissions it requires to manage resources on your behalf. And another policy is this guy, AWS EKS service policy, which allows Amazon Elastic Container Service for Kubernetes to create and manage the necessary resources to operate EKS clusters. You can get more information and from the documentation or from the AWS console. All right, and just go to the IAM and click policies, because those are all out-of-box policies you can choose from. So just search for AWS EKS. You can get all the policies available right here. And if you click inside, like for example, EKS cluster policy, right? EKS cluster policy, and here it shows the description to tell you what these policy for, and here you can grab the policy arm, right? And go back here, and here you need this policy arm copy paste from here. All right, and that's pretty much for the EKS cluster role. All right, the next role we gonna create is for the nodes. Here we go at line 34. Jump back to the documentation. Here we go. This is the documentation for EKS node IAM role, right? So here, as you can see, you must, before you create nodes, you must create an IAM role with the following IAM policies, which is IAM EKS worker node policy and EC2 container registry read only. Beside these two policies, there is a note right here. If the Amazon EKS CNI policy is attached to the role, we recommend removing it and attaching it to an IAM role. All right, so these basically what we need to do in our configuration. So back to Visual Studio Code, and here we go. So firstly, let's create a role. I'll call it EKS node group, right? So we need to ensure, again, based on documentation, these two policies, managed policies, are attached to the role. All right, and here for the role policy, you can copy from the documentation here. This guy, right? Copy these policy and put it here, and then we move to the next three required policies that need to be attached to this role. The first one is ECS worker node policy, right? And again, you can go to the IAM and search for that policy and grab the policy arm, like Amazon EKS worker node policy, right? Go there and grab the policy arm right here, right? And back to my editor. And the second one is the EC2 container registry read only, right? And there was the note about the EKS CNI policy, right? These policy basically provide the Amazon VPC CNI plugin the permission it requires to modify the IP address configuration on your EKS worker nodes, right? So here we go, same thing. That's pretty much the preparation we need to take care of before we deploy the EKS cluster. And here is all the roles and policies required. All right, so let's move forward to the configuration for our EKS cluster. All right, now it comes to the main Terraform configuration file for the EKS cluster. As you can see here, the first resource I defined was AWS EKS cluster. And I give a name as ZZ-Talk EKS cluster. The role arm will be the one we just defined in the IAM the Terraform config file to make it easier to refer. Let me split the screen like this. Alright, so here is the IAM file. On the right side is the EKS cluster.terraform. Alright, as you can see, I'm gonna refer to the role here, the AWS IAM role EKS cluster, AWS IAM role EKS cluster.arm, right? And VPC config, I'm gonna these EKS cluster will be hosted on the public subnets, the 3 public subnets inside of the custom VPC. All right, so that's how I define right here. So because I used module VPC module to create the custom VPC, so I can call it module VPC, and it's gonna be hosted on public subnets right here. And again, remember we attached to a policy as the prerequisites, so we have to make sure the policy, these 2 policies were defined before we deploy the EKS cluster, right? That's why I use depends on. So it makes sure these 2 policy, Amazon EKS cluster policy and service policy, were applied before we deploy this EKS cluster, right? Okay, and I give it a tag. Just call it ZZ-Talk EKS cluster. You can name it whatever you want. Moving next at line 19. So after we define the cluster, we're gonna define another resource for nodes, right? Workers, basically. So here I'm not just defining a node, but I'm gonna define a node group instead. All right. So here for node, the cluster name will be the cluster we just defined right above here, right? So AWS EKS cluster, and the variable is AWS underscore EKS, and name, right, is going here. And line 21, node group name, so just give a name, I'll call it ZZ-Talk EKS node group as ng, all right? And node role arm, so it's gonna come back to the IAM.terraform again. So I'm gonna refer to the arm that we define right here. The other role I defined, here we go. Line 34 in the IAM.terraform. So I'm gonna refer AWS underscore IAM role, and this one is for EKS underscore nodes, right? And arm, all right? And again, the node group or the nodes will be hosted on the public subnet as well. Here we go. Same as the cluster, all right? And here is scale and configuration. This is for the demo purpose. I just make everything as one to make our resources as minimum as possible. All right. Again, last but not least, there were dependencies, right? That's 3 policies or the dependency for this role. So we need to make sure these 3 policies were added before we create the worker nodes. Same thing like the master node or the cluster. So this is the EKS worker nodes policy, EC2 container registry policy, Remember here? That's what we define the policies right here in the IAM, the Terraform. All right, that's pretty much it. I think we're good to get it run. So, by the way, same thing for the providers, and here we go. The providers, inside of the provider, the Terraform, I define the first thing, of course, the AWS provider. Inside of the provider, I can define the default AWS region I'm going to use. In this case, I'm still going to use, I create a variable, it's called AWS underscore region, and I'll define that in the variable, the Terraform. And I will use the same region we did in our manual test previously, right? So, which is US East 2, right? And another two data resource I created right here at line 7 and line 12. So AWS region provides details about a specific AWS region, and AWS availability zones allows access to the list of AWS availability zones, which can be accessed by an AWS account within the region configured in the provider. In this case, it's going to be US East 2. All right. And last but not least, HTTP provider is just a utility provider for interacting with the generic HTTP service as part of the Terraform configuration. So you don't need to provide any, it doesn't require any configuration. You just put it right here. All right. Cool. That's it. Let's run Terraform apply to see how it goes. Oh, by the way, inside of the AWS provider, remember you need to define the your private information, your access key, private key, those stuff you need to define right here. Cool. Let's give it a try. Okay, let me switch to my terminal and I'm at the right folder. Okay, firstly, let me run Terraform init. So it's gonna download the module, the VPC module, right? So the initialization has been completed. So next, let's run Terraform plan. Just verify if there is any syntax error. All right, looks good. As you can see, there will be 28 resources in total being created after I issue the Terraform apply. Right? If you can, let's scroll up a little bit to see what resources will be created, and you can see the EKS cluster will be created. The node groups will be created. The IAM role for EKS cluster will be created. The IAM role for nodes, worker nodes will be created, right? And the policy attachment that we defined for the node and for the master will be created accordingly. And of course, the VPC, like internet gateway, all of those, route table, public internet gateway, private internet gateway, all of those, that was basically defined in that VPC module. Those will be created as well, right? Looks good. Let's issue Terraform apply. By the way, let's verify. So so here, let's jump to the AWS console and make sure I'm on US East 2, right? And click, let's say VPC. So right now, I only have one default VPC, right? And let's run the Terraform apply. and I will give a yes to continue. It's gonna take some time to deploy all of those resources. So let's be patient. And as you can see, those cluster VPC are being created, like route table, association, the AWS EKS cluster is being created. At the same time, let's do a refresh. And here we go. You can see the VPC, number of VPC jumped to 2 because more custom VPC are being created. See, ZZ Terraform EKS demo VPC, right? That's exactly what we defined here. We see VPC right here, right? The cluster name hyphen VPC, and that's the cluster name I define in the variable, the TF file right here, right? And what about the IAM role? So let's go to IAM. Let's see roles, and we should see, here we go, EKS node group and EKS cluster. That's the two roles that we created, we defined in Terraform configuration. And here we go, right? What else? Let's jump to the EKS. Let's check clusters. And here we go. This is the cluster we're deploying right now, and status still showing creating, right? So everything looks good. So let me jump back to the terminal and just be patient, wait for all those resources being created. Then we can jump back to the terminal, AWS console to verify. All right, looks good. As you can see, everything's green. So there were 28 resources added, and let's verify and jump back to the AWS console. And as you can see, the status showing active for our EKS cluster. All right, so let's go inside of this cluster and click configuration, and let's check. Let's check this networking, and this EKS cluster is hosted on the custom VPC, right? Let's verify that. Let me open another tab and go to VPC, and this is our custom VPC, right? And the VPC ID is 601, and switch back and 601, and the cluster, the master node, and the workers will be hosted on the 3 public subnets, right? Let's verify. Here's the subnet ID, and let's verify the subnets. The public subnets will be, so let me go back to Visual Studio Code and enter VPC. The public subnet will be 10.0.101, 102, and 103, right? So let's switch back. 10.0.101, this guy, and the ID will be E10, and 103 is 089. So here, E10 089 looks good, right? And that's for the EKS cluster. What about the worker nodes? The EC2. Let's jump to the EC2 instance. There should be, as remember, we only define one in the scaling configuration. Back to, we should do code one more time. And here EKS cluster, and here we go. The scaling config. The desired size is 1, and max size and minimum size both were 1, right? So we should be expecting only one EC2 instance up and running and hook up with the EKS cluster. So let's jump back to console to verify. Go to EC2 instance, and here we go. There's one instance up and running. Looks good, cool. And let's again go back to my terminal and just run kubectl get nodes. It should enable to connect to the server. Of course, that's because we haven't updated to our kube config to connect to that new cluster we just deployed, right? So because when you see Docker and Kubernetes, and right now it's not pointing to the right cluster, so we need to update our kube config file. So I'm going to do that by this command, AWS EKS region region will be US East 2, and update kube config, and name will be the name of the cluster, which is let's go back to EKS. The name of the cluster is this guy, ZZ Talk EKS cluster. Hit enter. Error occurred when calling the describe cluster operation. The security token included in the request is invalid. So I need to update the security token. All right. This is something with my secret key. So let me update real quick. This is something with my secret key. So let me update real quick. All right, here was the issue. Every time when you run AWS CLI and you got this error, it says the security token included in the request is invalid. It means something wrong with your private, the access key and private key. All right. So what you need to do, you need to double check if your key is still valid or is put on pending or inactive or something. So that's what I did. Basically, I just go to my AWS folder, .aws, and inside of this folder, you should be able to see a file called credentials. That's where the key was stored. So let's take a look. Here we go. I just updated my access key and secret key right here. So because back to the IAM, and as you can see here, my previous access key was inactive, and I create a new access key and private key and apply right here. Once I update that and rerun the update command to update the kube config, everything works as expected. Again, I will delete. This is something private. Don't share these keys to anyone. Otherwise, it's going to be a security vulnerability violation. All right, and I will remove these new keys right after this demo. Cool. So now we got update the command the access key and private key. Let's issue that AWS EKS update kubeconfig command one more time. Here we go. And then let's issue kubectl get nodes. All right, that's what we're looking for, right? We had one EC2 instance up and running as a worker, and it's reporting to our cluster. Cool. All right, that's pretty much what I want to share in the past 2 sessions. After these 2 sessions, I believe you had a good understanding how do we deploy the EKS cluster manually or via AWS CLI, and how do we automate this whole process via Terraform. Cool. Sorry, one correction here. When I say in the last part there was something wrong with my private key, access key, right? So I said update these, update the access key and private key in the credentials file. Actually, that was not correct. So you can do that for troubleshooting, but do not manually update, because we're trying to automate the whole process via Terraform, right? So everything has to be done by Terraform to follow the best practices. Otherwise, it's gonna be a problem. So what you need to do, you need to jump back to your Terraform config file. Remember, I put the access key and private key inside the provider. So you need to update your access key and secret key right here and reapply by Terraform instead of manually update your keys. This is important, and let's follow the best practice to avoid unnecessary errors. All right, that's pretty much what I want to update, and sorry about that. And all right, thank you, and I will see you next week.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.